Thank you so much, Mr. Tang. Our next speaker is an inquisitive cybersecurity professional who is currently intrigued by modern edge compute and its challenges. In his current company, he works towards understanding and mitigating the challenges the applications face as they are pushed to the edge. He frequently writes about IT security at f5labs.com and has co-authored a Redbook on access management deployment patterns. His work pivots on boosting security and visibility, intelligence, and automation. Let's learn about securing the edge from the Senior Solutions Architect of F5, Mr. Shahnawaz.
Hello and welcome everyone. My name is Shahn. I'm a solutions architect at F5 Networks. And today we'll be talking about securing the edge in the new norm. In today's day and age, we see there's a lot of data being generated. So one way of handling this data would be to funnel all the data that's being generated by our smart devices, our sensors, to a central location and let it take decisions by processing it. Or a smarter way would be to take this data, process it closer to the place where it was generated, and just send the processed data up for longer term analysis. And that would be the usage of edge compute. As more and more workloads find their way towards edge, it is of huge importance to understand the security threats to applications running at the edge and how to secure them. And today we will be going in a little bit of detail on how to secure this workload running on the edge. Before we go in depth of edge compute and the architectures, we need to first understand what is leading to all this. And the answer would be business transformation. There is digitalization everywhere. Every aspect of business finds some way in or form in the digital aspects of it. All this is leading to a lot of computing, and cloud computing is definitely on the rise. We can also see that Internet of Things is giving a new aspect or a new paradigm to way in which businesses are being done. With cloud computing, Internet of Things, the traditional data centers, we are seeing that there is a mix and match of different combinations of application deployment technologies being used. So there are more hybrid architectures to understand. So when we are going through all these complications, does this mean that security is having a day off? That's not true, because governance and risk compliance are more important today, if not less than ever. With all this in mind, we need to understand how the new deployment aspect of applications and workloads toward the edge would work. So take a deeper look into that. Let's take a look first into the application deployment landscape of today. Most of us would be running our workload in one of the three formats that we can see on the screen right now. Either things are running on premise for us, where our workloads, our databases, everything is at our data centers, which are managing. Or we might be a born in the cloud company, where we are taking resources from somebody else and consuming it in the form of infrastructure as a service, platform as a service, or software as a service. A much more common scenario would be the hybrid architecture, where a lot of organizations are. People have invested a lot in their data centers, and they're running state-of-the-art data centers with all the required compute and automation. But at the same time, they would require some of the innovative features that are coming out from the cloud. So there will be a hybrid of these two different kind of architectures communicating with each other to meet the requirement that the business has. Sometimes it will also help meet the security and privacy requirements, wherein the compute can be at one place, but the data is stored securely at another location. With this deployment landscape, we also need to understand the changes in the application delivery mechanism itself. If we look at how traditionally applications were being accessed or were being consumed was, there was user, and an organization would put up its services on the web server, so web somewhere. The user will be able to consume this service from the web. directly by knowing the URL and other endpoints. This was well and good till the time the load was low. These servers were able to take in all the capacity requirements. But as the popularity grows, there will be more and more people, and they will be trying to access more and more resources, which will be basically taxing the server that's running. And that led us to understand that in this architecture, there are a lot of static content which is there, which can actually be distributed closer to the user by the way of CDN, and the user can consume the static content from there, and they will still get the dynamic content served directly from the origin service. It was a fairly good architecture which served the purpose. And one of the important things that we need to understand in this particular architecture is the users are mostly the consumers. They're trying to consume the services that are provided from these websites. But as we talked about earlier, that in today's day and age, the users and their devices are not just mere data consumers. They also generate a lot of data that needs to go back up to the server for the organizations to take intelligent decisions, which leads to this architecture. So we can think about smart connected cars, your cameras, your smart homes, the user themselves. They're generating a lot of data. And one way, as we talked about earlier, was we can just funnel all the data back to the data center. It will choke the network. It might not be the most optimal way of doing it. On the other hand, uploading the data might not be the best thing because things like smart cars or cameras, they need to take just-in-time decisions in a distributed fashion. They cannot wait for the decision to come from the central server. If a car is driving, whether it needs to hit the brake or not, the decision has to be taken then and there by the device based upon the local factors or the local telemetry that it has computed. It needs the compute closest to the car itself. Another example would be, think about an IP camera and think about a case where the IP cameras are programmed to look for a specific person. One way would be the entire feed is collected, uploaded to some central server where the processing is done. Or another mechanism would be, you can have a set of servers sitting closer to the edge with few cameras, which is just processing the images, and only the one that is of interest is posted back to the central server. Helps you meet some of the privacy requirements as well, I would say. So this is the modern application. This is how we see that edge would really power some of the applications when it runs closer to them. This is not only meant for IoT and other devices, because we can also have the same construct meant for more traditional kind of applications. For example, e-commerce platform itself. So we'll look into more into the e-commerce example, but prior to that, let's talk a little bit more about the edge computing and the architecture itself. In a research paper about edge computing security, state of art and intelligence, we can see that the researchers and the authors distributed the architecture in 3 layers. We had the first layer, which is the edge device layer, which is where the device is sitting, which computes. It might be a sensor or it might be a smart device like a mobile device. They are collecting computing telemetry and data, which gets uploaded to the next layer, which is the edge server layer. The edge server is the intermediate processing layer where all the data that is being collected by the devices is processed, compute, and if needed, local decisions can be made. And it can then take the processed data and send the intelligence back to the cloud server layer where further processing of the data can be done. In terms of computation, the computation power goes up from the layer 0 to layer 3, which is the cloud server layer. When we look at the edge server layer and the cloud server layer, you can think about it like the edge server layer can be like a branch. So if you're an organization that's running multiple branches or multiple agencies, and each agency has certain amount of compute wherein they can take the local data, process it, and give decisions then and there itself. So it will be your edge server layer. It could be in a branch, or if you have a point of presence from a cloud provider over there, it could be a cloud based on a cloud as well. The cloud server layer is where your central data center is, where you do long-time processing, long-term storing of the data. It can be in your traditional data centers, or it can be on the cloud as well. So this is how the architecture of the edge compute environment would look like. Now take a take a deeper look into this and look at how an application would work when it comes to such an architecture. As we talked about earlier, I'm not going to take an IoT related application or a smart car related application, but we'll talk about a modern application that most enterprises use. In this case, I picked up a sample app from GitHub, and the architecture is right in front of you. It is basically saying that we have an app that makes the use of the best technology that is provided in the world. You making use of technologies like HTTP2, gRPC, having front-end, back-end applications, everything broken down into smaller, more modular pieces that can all communicate with each other. So in modern applications, this is what we see how applications are transforming. But when we are doing this transformation, we're also setting us up for the next layer of, or the next level or plus one ourselves with respect to our deployment architectures. Because if you look at this architecture, the application is broken down into smaller pieces that can be deployed separately and they communicate with each other. Which also means that if you have an application within Philippines that needs to be deployed in a way that people can consume it from different locations. Think about an application that needs to be consumed at individual provinces. Individual provinces might not have their own cloud endpoint, but an organization can have a branch over there or can have a small location over there wherein they can deploy the front end of the application. The front end, what I mean is, in case of e-commerce platform, the front end application will have the product catalog service, the cart service, and the recommendation service. Basically saying that users in one province will be able to connect back to the server. They will be able to see with lower latency, be able to consume the service that is provided to them. At the same time, when you have certain services that needs to be engaged, like payment services or currency services, these are actually a little bit more stricter in nature. They need a lot more security for them to run. They can live in your traditional data centers. So not by the virtue of having this application decomposed into smaller, more modular pieces, we can also play with the aspect that instead of deploying everything as one in one cluster, we can break it apart. We can deploy it in a way that it makes more sense. People can consume it closer to themselves, with the UI closer to them. And when they are doing certain sensitive transactions, they can come back to the centralized data center, and it works best for everyone. So this is how we will see more and more applications being designed, and they will be ready for you to actually deploy it closer to the user in a way it's more optimal for use. So applications have changed, and they will, and sooner or later, we might be able to push them closer to the user. Instead of just keeping static content and CDN closer to the user, we can actually bring the application or the workload closer to the user. But it definitely comes at some security risk, because now workloads are not running in your data center. The workloads are actually running closer to the user near the edge. But what are some of the security challenges that we can face at the edge? The first and foremost thing that comes to my mind is the diverse and the large scale of devices that we will have to deal with when we are pushing things towards the edge. Another important aspect to understand is when everything is in a data center, we put in a lot of resources to secure our data center. But when it goes out of the data center, closer to the edge, it might be vulnerable to some amount of unauthorized malicious software injection or even hardware tampering. So how do we take care of that? Because now the workload is running closer to the user and not in the secure data center. Another important aspect to understand is, what about the tooling? We have, say, 5 different edge locations. How are we going to effectively manage these different locations? At the same time, since we are delivering applications from this edge location, application and network security will be of importance. If somebody is staying closer to the application and tries to do an SQL injection on your application from there, how does an organization protect itself against it? If you have delivered your application closer to the edge, does it make any sense for your traffic to come back to a central data center, cleaned up from there, then go back to the edge location? It would be more important if the edge can pack the security with respect to application and network closer to it. And observability will be of paramount importance because we have such diverse device set, distributed across locations, how do we manage them, and how do we look at if everything is operating properly or not. So these are some of the key security challenges that an organization will face as they push their application towards the edge. But then that's just the problem. There are certain tenets that comes to securing the application at the edge. And first and foremost in my list would be secure communication. The edge, the central data allocation, and the management plane should be able to communicate in a secure manner that cannot be tampered with. Another important aspect is an enterprise should be able to push or enforce policies in a uniform manner across the different edge locations. If I have one version of application going to 5 different edge locations, I should be able to push the same policy to 5 different edge locations without any complications. Secrets management is an important aspect because, as we said, things would run at the edge. There might not be the same security level that these devices have at the edge. And that means if somebody manages to get hold of your server, if they manage to reverse engineer it, get the data out of it, they might get access to your secret keys, your passwords, etc. Because at the end of the day, your edge location would need these keys or your certificates to operate. They need to be kept in a safe and secure manner as well. We talked about application and network security that has to be inbuilt when applications are deployed in the edge. We cannot route the traffic somewhere away, then bring them back to the edge because it would not meet the requirements. And observability is a key. So to secure the workload or the application delivered through the edge platform, we need to manage or meet the tenets of the edge security requirements. So with the challenges and the tenets in mind, I would like to talk about an architecture that can help meet these kind of requirements. So on the screen on the left-hand side, you see a deployment architecture, which shows there are 3 different sites an organizations can have. So 3 is just a number, you can have 3 for that. So we have 2 edge sites, which can be coming from a cloud or which can be an agency of yours, which can be a branch of yours, where you're deploying some of your applications. The edge sites are delivering certain applications. They can be exactly the same applications or different versions of it, doesn't matter. As we talked about it, these locations need to talk to each other in a secure fashion. So how do we create a secure tunnel that the services running on edge site 1 can find the database running in the data center or can find a corresponding service on the edge site 2? We need a secure tunnel that can do that, which can allow discovery of services and also easy communication and secure communication with the different sites. Unified management would be a key for success for such an environment to work. With zero touch, we should be able to provision services, manage services across these 3 data centers. So with this kind of architecture, what we can achieve is we can achieve identity management across different sites, which will help us manage identity for sites and workloads. Unified management, if it's designed in the right manner, you will be able to do secrets management or secrets enforcement. Secrets can be kept, encrypted, and passed on to the devices in such a manner that they cannot be reverse engineered or nobody can get direct access to them. More importantly, this kind of architecture can help you cater for network and firewall policies that can be centrally controlled. And also the ability for you to manage applications in a way. So as an enterprise, I can think of, say, the same e-commerce use case. And I want to say that province 1 is edge site 1, province 2 is edge site 2. Both of them need a version of an application. From one location, I can push the same application as in one single configuration rather than touching each individual server and managing them myself. That would be the true power of edge compute when it is implemented in the right way. One of the most important constructs for such an architecture to actually succeed is to have zero-touch provisioning. We cannot say that every time somebody needs to manage an application, somebody needs to go down to the edge location and do it. The unified management should be able to take care of almost all kinds of lifecycle related events as well as application delivery events to these locations. On which such an architecture, we will be able to achieve security for applications in the edge era. Coming towards the last slide, I would like to just summarize some of the key points that we talked about in today's session. We talked about how applications will be pushed towards the edge because the consumption of the application is nearer to the edge and the data generated is nearer the edge. So the lower latency requirement and the processing requirement will push a lot of workloads closer to the edge or closer to the user. As we move applications closer to the edge, there will be multiple locations, which will basically increase the threat surface. So that should be an important consideration while designing such applications and such edge locations. Another important aspect would be with distributed location devices, etc. The need for uniform policy enforcement would be very high. We cannot leave it to luck or chance that human mistakes can cause, because if a human is actually going to individual locations and performing these activities, there might be gaps, there might be loopholes. One central location should be able to do all this and should be able to enforce them. The same central location would also be critical for having visibility and control into all these edge locations, which will be needed for the success. Another important aspect would be to have secure site-to-site communications. So with these key takeaways, I would like to thank you all for listening to the talk. I hope you'll take back something about applications, the evolution of the applications, and how in the next step of evolution, we will see this application will be distributed towards the edge. And when we distributed the application towards the edge, we know the security requirements, we know the security challenges and the tenets to secure it. Thank you very much.